Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zakir Hanan. Today we're going to present to you our sustainable material topic, which is about biocomposites. So you go through the slide. So the first one is table of contents. So the first one we proceed to is introduction. So for introduction for biocomposites, biocomposite is a composite material formed by a matrix, resin, and a reinforcement of natural fibers. Over several years, fiber reinforced composites have been attracting great interest because of their many superior properties and applications. The well-known fact is that the reinforcement of fibers in different polymers significantly increases the mechanical properties of the composites. Furthermore, advanced study has found the rising performance of composites with 2 or 3 polymers reinforcement or failures. However, due to difficulties in separating the components of these composites, recycling is challenging. On the other hand, these composites have a negative impact on the environment when they are disposed of in landfills or burned. So proceed to the next slide, which is objectives. From the 3 articles, for the first article, the objectives is to utilize the Ecovio F blend C224 as a binder with 4 types of industrial waste, which is rice husk, wheat husk, wood fibers, and textile waste fibers, to develop a thermal insulation composite for interior building materials. For the second article, the objective is to develop that palm wood as a new biocomposite material used for thermal insulation in a building or in the solar thermal panels with low thermal conductivity and density using a natural low-cost gypsum fiber or component material. For the third article, the objective is to test 5 different wood waste-based fillers such as unclean and clean pine wood, sawdust, pine wood bark, hemp from Lithuania, and hemp from France, and select the one with the best potential for the replacement of biocomposite foams with different binder, filler, and ratios. I proceed to the next slide.
So, my name is Muhammad Faiz. So, for the slide methodology, we compare 3 procedure of the 3 research. So, next.
Oh, sorry.
So, for the first article, the procedure to prepare the biocomposite is first we dry the sample of husk or fibers in an oven overnight to remove its moisture. Then we dissolve the binder Ecovio F in chloroform at room temperature, and then use a mechanical stirrer to mix the binder with dry husk or fibers. And then we dry the mixture in a fume hood for 5 hours to remove the solvent from the mixture. And then we hot press the mixture in 2 stages of heat to form a target thickness composites of 2 cm. And then lastly, we cut the composites into several pieces before analyze it with thermal properties using differential scanning calorimetry, DSC. And then for the second article, the procedure is first we prepare with 7 different mass fraction of dead palm fibers, and then mix hemihydrate gypsum powder and water in the automatic barrier blender. And then the fiber were added to the mixture and mix for a few minutes. And then we verse the blending quickly in the mold. And then we use the CT meter instrument to determine the thermal conductivity of composite samples. And then for the third article, the procedure is first we reprocess polyol catalyst and surfactant was stirred together for 1 minute at 1100 RPM, and then the obtained mixture was mixed with the appropriate weight of isocyanate and stir for 10 seconds to obtain the polyurethane binder. And then the polyurethane binder is put onto weight amount of WS filler and thoroughly mixed for 1 minute at 1800 RPM. And then the whole mixture was put into a certain size mold and kept for another 24 hours. And then we use and then we test the thermal conductivity using heat flow meter apparatus FOX 304. And then for the data and finding, we compare all the three research, the test of the thermal conductivity for the three research. The first article, the data present in the table above show the density and thermal conductivity of the composite used in the research. All of the produced composite exhibited low density that range from 378 to 488 kg per meter cube. And then the thermal conductivity of the porous material is a combination of conduction, which is the chemical nature of the fibers or husk of the binder, and convection, which is air. The chemical nature of the fiber or husk of the binder is what lead to the difference in thermal conductivity. For example, Rihas or Ecovio F binder. And with husk or Ecovio composite exhibited the lowest thermal conductivities and about 0.08 and 0.01. Whereas textile fibers, Ecovio R wood fibers or Ecovio R composites had the highest one. The thermal conductivity, heat capacity, effusivity of each composite increase when the density increase. Only the diffusivity decreases. So next, for the second article, we can see that the table above show the comparison of thermal conductivity and density of some composites filled with natural fibers. And then the table show that the thermal conductivity also increased when the density of the composite increased. And the last article, from the table, you can see that the thermal conductivity different from all type of food waste. There's 5 type of food waste. The first one is unclean sawdust, UWS, clean sawdust, WS, wood bark, WB, titanium ham shift, HSLT, and French ham shift, HSFR. The blank symbol, single value from thermal conductivity measurement, and the full color symbol is average value. So the thermal conductivity of all wood waste base filler can be seen in range 0.046 to 0.061. The lowest thermal conductivity was determined for WS filler, for WS clean sawdust filler. This may be because of the filler structure, and the highest thermal conductivity value is wood bark filler, WB filler. This might be attributed to the size of the ham particle and the bark density. And obviously, the highest thermal conductivity value, the best the filler is to become thermal insulation biocomposite. And then we move to the next presenter.
My name is Ahmad Firdaus bin Rahim. The next slide is a contribution slide. The contribution is biocomposite sustainable? Based on my opinion, biocomposite is one of the most sustainable method of replacing traditional synthetic polymers or composites that is structured with inorganic synthetic fibers. This is because biocomposites are biodegradable, making them environment friendly and less pollutant. Most of the biocomposite materials are made with waste materials and natural resources such as coconut husk, rice husk, and barley husk fibers. Next, although the usage of biocomposite has many drawbacks, such as having inconsistent natural properties, it is also cost lower than synthetic fibers because they are abundantly available. Next, biocomposites are also a renewable material because most of them are made with natural resources, such as woods. Natural resources can be replenished. For example, trees that are cut down to make woods can be replanted, and harvested again for generation to generation. Next.
Sorry.
Next is a slide of the witness. Next. The witness is the first research was using this industry waste and very low in cost, but the binder Ecovio F and chloroform used were a bit high in cost, and the preparation of the sample take a long time than others, as the sample need to be dried overnight in oven. The second research was using date palm fibers from date palm wood. This will need to cut down a lot of trees. Construction in long term. The third research were using 5 different wood ways to find the best potential for the replacement of biocomposite forms with different binder or filler ratios. This research will need a lot of samples that are troublesome to find all different types and a lot material for binder, resulting in high cost. So the next presenter.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Fikin Rajab bin Ismail, and I'll present the 8th slide for the conclusion. So for the conclusion, from the article 1, agricultural waste, such as cereal.
The knowledge gap.
I will present about the slide 7, knowledge gaps. Okay, the knowledge gaps from these 3 articles of sustainable biocomposite that we study. The main of our research is to find the best biocomposite with thermal insulation for building materials. All the research are successful, which all the sample already been testing with different method of thermal conductivity, and all of them pass. A thermal insulation material is one which frustrates the flow of heat. It will slow down the rate of heat loss from hot surface and similarly reduce the rate gain into a cold part. It will not stop the loss or gain of heat completely. For further improvement, I would suggest that the research also test for the time the heat maintained in the desired temperature levels and how long the sample can keep generating heat. A well-insulated sample will maintain the heat of its content for a longer period and keep the temperature stable. And for the next slide, slide 8 for conclusion. From the article 1, agriculture waste such as cereal husk and textile waste bind with a bio-based resin, ECOVIO-R, were developed for composite installation panel applications. We have investigated the performance of the developed composites under actual working conditions, and the result obtained show considerable promise in developing a new class of sustainable materials for building interior insulation application. And for the article 2, the experiment successfully analyzed the use of DPF as reinforcement in gypsum matrix. The thermophysical behavior investigation shows that the increasing of DPF concentration in gypsum matrix decreased the thermal conductivity and density of composite. And for the article 3, it studied various WW-based fillers such as UWS, WS, WB, HSLT, and HSFR were investigated. The obtained result for apparent density and thermal conductivity were approximate by regression equation, which showed that the parameters are dependent on the PURB over WS ratio in PUR biocomposite form by 96% and 97% respectively. And the next slide is the recommendation of the best. Based on our discussion, we conclude that the most reasonable method is from the article 2. It is because the low cost of the productivity to perform the investigation. It is also the least dangerous experiment to choose because we conduct the experiment using natural composite material. And we also can conclude that this experiment have the lowest thermal conductivity to get the optimal thermal resistance. And for next slide is the articles and reference. Okay, this is our
Appendices.
belum.
Appendix.
So
For
we'll proceed to our 10th slide, which is the appendices. So as you can see from the figure 1, this is the biocomposites. Figure 2, husks and fibers. Figure 3, different sizes of dead palm wood. And figure 4, a pile of different types of wood waste. That's all from us. Thank you very much.
Thank you.